Hello everyone, myself Sindhuja. I am from branch EC. My roll number is 23401A0487 and the subject is control system. I took the topic numerical problem on state space analysis and the subject code is 2388404 and title is numerical problem on state space analysis. Let us know what is meant by state space analysis. State space analysis is a useful technique to analyze and design of systems. It can be applied to linear, non-linear, time variant and time invariant. SISO is nothing but single input, single output. MIMO, multiple input, multiple output. In state space analysis is represented by a mathematical model consists of set of input output state variables related by first order differential equations. State space is defined as the n-dimensional space in which the components of the state variable represents its coordinate axis. Second order system state space. In case of second order system, state space is two-dimensional space with x1 and x2 as its coordinates. Basic concepts of state space analysis. Let us know what are state, state variable and state vector. Definition of state is it is a group of variable which summarizes the history of the system in order to predict the future values. The future values is nothing but the outputs. State variable. The state variable of dynamic system or the smallest set of variables that determine the state of dynamic system. State vector. If n variables are needed to completely describe the behavior of the dynamic system, then n variables can be considered as n components of vector x. Such a vector is called state vector. Steps to solve a numerical problem on state space analysis. Step 1. Define the system equations. A system is typically described by a differential equation in the time domain. an into d power n y by dt power n plus a into n minus 1 into d power n minus 1 into y by dt power n minus 1 and so on. A power a1 dy by dt plus a naught y is equals to bm d power m mu by dt power m and so on. b1 d mu by dt plus b naught mu, where y of t is output of the system, mu of t is input of the system, an minus 1 and so on. A naught are the coefficients of the differential equations, bm minus 1 and so on. B naught are the coefficients of input function. Step 2. Define the state variables. To convert the system into state space form, introduce state variables. Let x1 is equals to y is the output, x2 is equals to dy by dt, first derivative of output, x3 is equals to d square by dt square, second derivative of output. Continue this process until the highest order derivatives is expected as a state variable. Thus the state variable becomes x equals to x1, x2 and so on xn. Step 3. Write the state equations. Now express the system in first order differential equations. X dot is equals to ax plus b mu. Bu, where A is state matrix, describe the system dynamics. B is the input matrix, describes how inputs affect the system. Step 4. Write the output equation. The output equation is given by y is equals to cx plus du, where c is the output matrix, maps state variables to the output. D is the feed forward matrix, describes direct input output relations. Step 5. Express in matrix form. The complete state space representation is as shown in the figure. Finally we get the output as y is equals to c1 c2 and so on, cn into x plus d into mu. Step 6. Analyze the system. After obtaining the state space model, the system can be analyzed using eigenvalues of A. Eigenvalues of A is nothing but determination of system stability, controllability and observability. Check if the system can be controlled and observed. Solution of state equations using matrix exponentials or numerical methods to solve for x of t. Let us take the example problem on state space analysis. Determine the state equations of the system whose transfer function is given by g of s is equals to 100 by s into s square plus 0.1 s plus 10. The solution is, let us take g of s is equals to, we know that y of s by mu of s, that is equals to have g of s is equals to 100 by s into s square plus 0.1 s plus 10. By multiplying s into s square plus 0.1 s plus 10, we get s cube plus 0.1 s square plus 10s into y of s is equals to, by cross multiplication we get 100 mu s. Taking inverse Laplace transform, y 3 dot plus 0.1 into y 2 dot plus 10 y dot is equals to 100 mu. Let it assume as 1. We get y 3 dots is equals to 100 mu minus 0.1 y 2 dot minus 10 y dot. Let us take y is equals to x1, differentiate y is equals to x1, x1 dot is equals to x2 is equals to y dot, x2 dot is equals to x3 equals to y double dot, x3 is equals to y triple dot, x3 dot is equals to y triple dot. As we know that y triple dot we got as 100 u is equals to 0.1 x3 minus 100 x2. So the derivative of all these three state variables are obtained. Now state model will be x1 dot, x2 dot, x3 dot is equals to 0 1 0 into 0 0 1 0 minus 10 minus 0.1 into x1 x2 x3 plus 0 0 100 into mu. 0 0 100 mu is nothing but d. Output of equation y is equals to x1, y is equals to 1 0 0 into x1 x2 x3. And the conclusion is that state space analysis is a powerful mathematical framework used to model, analyze and design dynamic systems by representing a system behavior in terms of state variables and their time evolutions. And its applications extends across the various engineering fields, ensuring precise system modeling, stability analysis and optimal control design. Thank you.